Let us take a case of a concave mirror, but in this case, DO, the distance of the object, is less than F. In this case, I'll set up F is equal to 12 centimetres. DO, the distance from there to there, 6 centimetres. Because this is where the mirror is. This is a concave mirror. Remember, we're drawing the little optical shape. This is my line of action, this is my neutral axis. So from the mirror, F is 12. From the mirror, DO is 6. So how do we draw this? And again, we do the same thing. We go, the first line is parallel, then through F. Okay, this is going to be a little more tricky. But when we say F, I'll show you what I mean when I say through F. So the first thing we do is we draw parallel. So let's make sure. So that's going to be parallel. That is there, and this is parallel to that one. Okay, the next thing is we've got to draw it through F. The focal point is over here, so it's going to bounce back, because it's a mirror, remember, it bounces back, and it's going to go through F, like that. Okay, hopefully nothing tricky there, so that's pretty much what we did in the first one, because a mirror reflects, it bounces. But the second one line goes through F, then parallel. But remember how I've been trying to get you to do this all the way along. What I've said is you put the ruler on F and the tip of the object, and then you draw the line. So I'm going to put from there to there. I'm just going to draw a dashed line going up to the tip of the object, and then it's a solid line from there up to here, and then it bounces parallel. So then it goes bounce. So the ray of light goes from here up to here. And now we've got an interesting position. What we say is the image forms where these rays meet. But you can see these are converging, these are getting further and further apart, and they will never meet. So how can we get the lines to meet? And the answer is what we do is we backtrack the reflected lines. This one goes up here and reflects that one. So I'm going to backtrack this reflected line. And the way I do that is I'm going to draw it as a dashed line. Hopefully a better quality dashed line than that one. And this line goes down here and then reflects down here. So I'm going to backtrack that reflected line. So look at the reflected line, and I go on the other side of the mirror, and hopefully at some point these two lines will actually meet. There we go. And they meet here. So in this case, the image is going to be behind the mirror. We're going to look into the mirror and see the image over here. And so we can then do the big three that we've done before, upright or inverted. And we look at the image and we can see their image, the arrowhead is pointing up, so that's upright. We then go enlarged or reduced. We look at the image, and the image is, and there's the object, much bigger, so it's enlarged. And then we have to go real or virtual. Basically, can I pick a piece of paper there and see an image? And the answer is no, there's a mirror there. No light actually physically gets there. Remember also the quick and dirty way, we can look at this and go, oh, these lines are dashed. These are not real lines. Therefore, this is a virtual image. We can never project that on anything. So, the important thing here, we draw our line parallel through F. We draw our line through F, and whenever I say we draw it, we put one part on F, we put one part on top of the arrow, draw the line, reflect. We then backtrack the reflected lines, and that tells us where the image is going to be. And then if we want, we can do it the normal way. DI, in this case I make 13, I suspect I'm wrong, but we'll check that with math in a second. And HI, make HI equal to 6 centimeters. Okay, so now we can check this with math. Remember, we do this exactly the same way as we did before. So F is equal to negative 1 is equal to DO negative 1 plus DI to the negative 1. We rearrange this, DI. We rearrange this for DI, so minus DO minus 1. That cancels that. So DI minus 1 equals F minus 1 minus DO minus 1. Rearrange that. So we go DI equals F minus 1 minus DO minus 1. Stick in the numbers. DF is 12 to the minus 1 minus 6 to the minus 1 all to the minus 1 equals 12 prime minus 6 prime. I know what the answer is, but let's do it anyway. Take the inverse of that, equals 12 centimeters. So my drawing skills were not fantastic. Okay, the next question is, what's the magnification? How big is the image? Lots of ways of doing this. We can go, let's just use the one we did before, HI over HO equals DI over DO. So HI equals HO DI DO. Just multiply both sides by HO and that gets rid of that. So equals HO is 3 centimeters times DI is 12 over hold on. Yeah, DI is 12 and DO is 6. Over 6 centimeters equals 6 centimeters tall. So this image is, yeah. Well, how much bigger is it? MI magnification equals HI over HO equals, well, what's that going to be? It's 6 centimeters tall divided by 3 centimeters, because that's how tall the object is, equals 2. So that means this image is twice as high, twice as big as this image.